with three variables, we're going to have an x, a y, and a z. Or it could be like a, b, c. It doesn't have to be x, y, z, but you will have three.
Variables for the three variables.
There are 4 blanks.
Yeah,
Steps.
4 steps. If you follow these 4 steps, it will get you to the answer every time. If you're a step-by-step person. So, step 1 is you will eliminate the same variable from 2 equations.
We'll always have a same variable.
It won't always be like the x's or the y's or the z's. It is up to your discretion.
By same variable, is that like a positive x and positive x, or like a positive and a negative x?
Positive and a negative.
Okay.
So, essentially, you're doing elimination for 2 equations on 1 variable. Then you're going to choose 2 different, yeah, opposite. Well, it's the same variable, opposite signs. So, like a negative x and a positive x. Then you're going to choose 2 different equations, because you're going to see that there will always be 3. So if you did the first and the second equation, now you can do the second and the third, or the first and the third. You're going to choose 2 different equations and eliminate the same variable as above. So if you eliminated x's in the first time, then you have to eliminate x's the second time. From there, you're going to solve the system. Now it only has 2 equations. So it's just a 2 by 2. Like we did before, elimination or substitution.
So when you say solve the system, is that when you're doing
like what we just did before. So essentially, like steps 1 and 2, we're just trying to get rid of the third variable. And it'll make more sense once we do it in an example. Then we'll solve. Then the last step is substitute to find the third variable. If these steps confuse you, then just kind of go off of what we're doing in the example. I think a little bit of a combination of both is going to be key. The whole premise is you're trying to get rid of the third variable, so that's what steps 1 and 2 are doing. Then step 3 is just like what we did in the last set of notes. It's just like the 3.2 stuff. Then once you get those 2, you're going to go back and find the third variable.
Wow.
So it's like you get rid of it, you solve, then you come back to it. Now that you know, this is one of my favorite lessons. I think you'll appreciate it a little more.
But now you're going to expect
Okay, what we want to do is we want to try and eliminate a certain variable completely. Okay? Now, just looking at this, is there anything that can be eliminated from 2 of the equations already? Y and negative y. Y'all see that?
How do you not see that number?
Yeah, and the z and the 2z. You could also do that as well. You can do either one, but I want you to do it the way I do it first so that you can keep track. Okay? So I'm going to choose the y and the negative y.
Whoa.
So I'm going to take these 2 equations and I'm going to eliminate the y. So I'm going to add down. So 2x plus 3x becomes 5x.
That's too much space.
Z and negative 2z becomes what? Minus z. And then 8 and negative 1 combined to be what? 7. Good. That was step number 1. I eliminated a variable. Now I need to choose 2 more equations to eliminate y from. it can either be the first and the second, or it can be the first and the third. But since we've already used the second and the third, we can't do that again. So let's choose the first one. And you want to do the second one? Okay. Doesn't matter. You can do either one. To eliminate the y's, I'm going to have to multiply the second equation by what? 3. So I'm going to rewrite the top one just so I can stay organized. I'm going to take this second one and I'm going to multiply it by 3. When I do that, I get 6x minus 3y plus 3z equals 24. Wait, is that right? 8 times 3, 24. Yes. So you see how I got that? I just multiplied by 3.
Why did you multiply by 3?
Because I want to get rid of the y's.
Oh.
Then when I add down, the y's are now eliminated. I have 7x plus 5z equals 29.
I don't like Z. It looks like a 2.
It looks way too.
Okay. From here, I now have this equation and this equation. And it looks just like what we did earlier, where I only have 2 variables. I can now solve by elimination or substitution, either for x or for z. So I want you to try doing that, and I want you to get x, and I want you to get z. I want you to get a number for both of those. So I'm just going to rewrite my 2 equations that I have. I've got 5x minus z equals 7, and I have 7x plus 5z equals 29. This is a z. I can solve by substitution, or I can solve by elimination. Yep.
Are there situations where you only can use substitution or elimination? Or
No.
so you can just pick one method and use
I'm going to usually specify which one I want you to use.
Boo.
Yes.
Is the order matter? Like, could you put the 7x equation on top?
No, yeah, that you could do that.
So we're trying to.
So I want to get x and z. I want to find a number for both of those. So this was step 1. This was step 2. This is now step 3. I'm just solving the 2 by 2 system.
What do you mean 2 by 2?
Like I have 2 variables and 2 equations. We started out with a 3 by 3. Like I have 3 equations and I have 3 variables.
We're also
Yes.
getting Y as well.
So after you have x and z, you will do step number 4, which is plugging back in to get y.
So, can you plug into the equation that you didn't use, or can you just plug in negative?
Yeah.
Any of the 3.
Let's do it on Z.
Okay, just looking at these 2, what do you think is the best way, elimination or substitution?
Oh,
I'm
just
feeling
I like substitution because I've got this z right here.
So would you put that whole equation into?
So z equals 5x minus 7.
Oh, hilarious. Okay.
And then I plug it in here. So 7x plus 5x minus 7 equals 29.
Wait, are we finding all 3 variables?
Yes. Once you get to this point, it gets kind of fun because this is where you start getting all the answers.
I'm not sure if fun is nice.
All of your hard work has paid off.
That's plus 35.
So you got x equals 2. What does z equal?
It's minus
3. Wait,
No, it's not.
Minus 3.
You add 35.
So I've got 2.
Where'd that method come from?
I've got 3.
It's negative z.
And now, finally, I'm going to take these two numbers, x and z, and I'm going to plug them into one of the equations. It doesn't matter. I usually always use the top one.
So much room for the world.
This is why you have to be careful.
What did I get? -5.
So 2 plus 3y plus 2 times 3 equals 5. So I plugged in for x and I plugged in for z. I left y by itself because I don't know what it is yet.
Can you pick any one?
Yeah, you could do the first, the second, or the third. So 3y plus 8 equals 5. 3y equals -3. Y equals -1. So now I'm going to write it not as an ordered pair because I have 3 numbers and it's going to go x comma y comma z. So 2, -1, 3. Now you can always check your answers. So the good thing about this is you can check your answers to know that you got them right. You can do that by plugging in x, y, and z to check your solution. So any of the 3 equations, if you go back and check them, they should work for all 3.
So,
Yes, David.
so it will always be the variables x, y, and z,
Mm-hmm.
and z will always go on the end.
Yes.
Oh my gosh, never mind. That makes sense. X, Y, Z. Wait.
Okay.
Actually, no. It's
Now, steps. Let's just discuss them. You want to eliminate one variable completely.
Can we do the
eliminate
y?
Y.
Let's eliminate y.
Negative 5y and plus 5.
No,
Okay.
top and bottom. So it's three.
Do the top one and the bottom because the middle one is.
So here, the y's will cancel, and so will the z's.
Whoa.
It's our lucky day.
Oh my gosh. Yay, Jesus.
So -4x. Yes. So x equals -4. Now, I want to do 2 more equations to cancel out the y.
The first and the last.
The first and the last. Good eye. That's a good eye right there. First and the last. The y's cancel again. Add down, and I get what?
6x plus
-6x plus z
z
equals
equals 22.
22. Now, something beautiful that happened is I already got a number for x. So what can I do? Yes, this one was easy. So I can plug it in right here. So -6 times -4.
-2.
I know, so do mine.
Wait, why is there another 2?
Oh, I thought that was a 2.
Okay,
Z.
now it just
Now I have to just find what?
y
Y. So I'm going to take my x and my z and I'm going to plug it in
to the
to
bottom one.
any of them. You want to do the bottom one?
Yes, please.
Okay. I kind of hate getting 0,
Okay, I was like, wait, hold on.
but you do get 0. I'm sorry I spoiled it.
Trying to learn.
Application.
Did you say that's a new one?
Terrible. It was funny.
Let me give you some advice with this, and I want everyone to listen. So put your pencils down and just focus for a second. Not you. How do I know which variable to choose? That's like a life question right there. No,
Z
you
is
don't.
so much easier to
Why is Z easier, Graham? Why is Z easy?
It goes into all of them.
Right.
Easily.
All of the coefficients are easily divisible by each other. So, like the 3 can go into the 6, and then the Z can go into the 6. With the X's and the Y's, I've got 3, 2, and 4. At some point, I'm going to have to multiply both of them by a number. And same with the X's. They're not easily divisible by each other. The least common denominator between those is 12. So I'm going to choose the Z's. So let's take step 1. It doesn't hurt even if you've already done this to just kind of let it sink in again. So you've already got it written down, then just watch me and let it just soak in the knowledge. So step 1 is I want to eliminate. I'm going to choose the second and the third one first. To eliminate the Z's, I need to multiply this first equation by -2. So I've got negative 8x minus 4y minus 6z equals 2. From here, the z's will cancel. I add down. I have negative 5x minus 8y equals negative 17. So that is step 1. Step 2, I'm going to choose 2 different equations to eliminate the z's. I have to eliminate the z's again. They have to be the same variable. So I'm going to choose the first and the second equation. It doesn't matter if you did something different. To do that, I need to multiply the top one by not by -3, just by 3. So to do that, I got 6x plus 9y minus 3z equals 15. And I'm going to rewrite the second equation just so I keep all of my things in order. Then I add down 10x plus 11y equals 14. Here are my 2 equations that I can now solve with 2 variables. Elimination, substitution. I'm going to rewrite them one on top of the other because I like to stay organized so I don't make a mistake. Now, doing this, which one makes the most sense, elimination or substitution? Elimination, I'm going to multiply what by what?
-5, all that 1 by 2.
Good. So that gets me negative 10x minus 16y equals negative 34. Eliminate. Negative 5y equals negative 20. So y equals 4. This is where the fun part starts. I mean, I think the whole thing is fun personally. Once you get one answer, you take that, you plug it in to one of these equations to get x. So I'm just going to do the top one. Negative 5x minus 32 equals negative 17. Negative 5x equals, what is that? 15.
Is your fiance aware of this?
Yes. X equals negative 3.
No,
You like
I
math
wasn't
too.
meaning. I was just thinking it's a joke, guys. Not actually.
From here, I'm now going to take these 2 numbers and plug into one of the originals.
As a child, all the Thornhill Springs grew up playing the games and
2 times negative 3. Stop. 2 times negative 3 plus 3 times 4 minus z equals 5.
What's a good sign for
6 minus z equals 5. Z equals 1. So final answer, 3, 4, 1.